Hello everyone, good afternoon. I'm Simran Joslal and it's my pleasure to welcome you to the Laser Talks 24. Today we are honored to have Dr. Patrick Summ, Dr. Patrick Summ, Managing Director of Optronis GmbH as a guest speaker. Dr. Summ earned his degree in electrical engineering from the University of Offenburg, Germany, and received his PhD in electron optics from University of Strasbourg, France. Following his doctoral studies, he worked as a system engineer, specializing in streak cameras and fast-gated intensifier cameras with ARP and photonetics in France and Germany. Over the course of his career, he has gained extensive experience in high-speed imaging technologies and advanced optical.
Simran, you are on mute. Simran, you are on mute.
Am I audible now?
Yeah, in between, you suddenly became mute.
Okay. Okay, do you want me to start again? Or was I not audible for too long?
After you have introduced Patrick and his doctoral studies till Strasbourg, and then suddenly you became mute.
Okay, I'm so sorry about that. Okay. So I'm audible now, yeah?
Yeah, of course. Yes.
Okay, so following his doctoral studies, he worked as a system engineer specializing in streak cameras and fast-gated intensifier cameras with ARP and photonetics in France and Germany. Over the course of his career, he has gained extensive experience in high-speed imaging technologies and advanced optical systems. Currently, Dr. Summ serves as the Managing Director of Optronis GmbH in Kiel, Germany, a leading manufacturer of high-speed machine vision cameras and streak camera systems. We are delighted to have Dr. Summ with us today and look forward to hearing his valuable insights and expertise. And also, if anyone has any questions during the sessions, please feel free to drop them in the chat box and we'll do our best to address them after the session. So everyone, please join me in welcoming our guest speaker, Dr. Patrick Summ. Patrick, thank you for joining us today. It's truly a pleasure to have you as part of Laser Talk series. Over to you now.
Thanks a lot, Simran. Thanks for the introduction and thanks for the organization of this meeting. I'm really happy to be here and to have the possibility to make some information and to provide some technical information about CoaXPress and especially machine vision cameras with CoaXPress interface. So I just want to introduce myself. I'm Patrick Summ, Managing Director of Optronis in Kiel. Kiel is a small city in the southwest of Germany. And today we have summer, but normally it's raining here, and so the weather is not as good as in India. So let me start about what we are doing and what we are talking about. We are talking about the CoaXPress standard. I will explain why there is the bandwidth requirements. I will explain something about history of CoaXPress and the basics, how it's working, about the physical topology and the signal and data flow, as well as different configurations, and also comparing the CoaXPress interface with other digital interfaces to transfer image data. First, CoaXPress is a standard introduced in, I think, 2011, by the GAI. It's a Japanese Industry Imaging Association. And the standard itself is an industry standard, and the GAIA is organizing also regularly electrical compliance tests. So the cameras or the frame grabbers having this interface are verified physically whether they are compliant with the standard. And there are also 1 or 2 times a year interoperability tests. This means that the community manufacturing cameras and grabbers meet, and then all the cameras are connected to different grabbers, and we see whether everything is working. So the standard is kind of verified by this organization. Why do we need this kind of standard? Well, if you have a look on the video systems or television systems, if you have a look on high-D television, you have something about 2 megapixels and 50 frames per second. We have at higher resolution 4K at 8 megapixel and 50 frames per second, but the data rate is quite moderate. And additionally, those images are transferred with compression algorithms. In machine vision, compression is typically not used. And if you look on sensor data rates at 1 megapixel and 2000 frames per second, you already need transferring 25 gigabit per second. The same is for 16 megapixel and 160 frames per second. So we are manufacturing, we can say, high speed cameras, but we are more focusing on saying high data rate cameras, because if you have high resolution, the data rate, the frame rate drops dramatically. The actual standard of CoaXPress is providing up to 50 gigabit per second. So we can transfer 1 megapixel at 3500 frames per second, or you can transfer, I hope you see my mouse pointer, you can transfer 165 megapixel at 70 frames per second. Next standard will double this data rate. This is the red line here. And we are actually introducing a camera with 9 megapixel and 1000 frames per second. And we will soon introduce also 21 megapixel and 450 frames per second. Those data rates are data rates, as I explained, that are transferred without any compression. Therefore, we need this high data rate. What is the history of things? In 2000, there was a first standard which was called Camera Link. It was using up to 10 twisted pair lines, each one transferring 85 megabit per second. So the Camera Link interface allowed to transfer digital data, digital video data, in a deterministic way at 850 megabit per second. This became quite soon too slow, and there had been two new standards. There was a Camera Link HS, so it's Camera Link high speed. It's the lower one, it's this one here. And this one was either using also twisted pair lines or already fiber links. And in parallel, there was the CoaXPress standard, which was using simple coax lines, so very simple. And this became more or less the industry standard. Today, most machine vision cameras that require really deterministic data transfer are using this CoaXPress standard. Camera links is still used for some scientific applications, so it did not disappear, but it's for industry applications, CoaXPress, which became the standard. This CoaXPress 1.2 evolved towards CoaXPress 2.0 with typically up to 4 lines transferring 12.5 gigabit per second, still with copper. And some year later, we have also this fiber optic transfer option, which allows to transfer over longer distances. Machine vision is still using typically this CoaXPress, this copper lines. Fiber optic is more exotic application, but when we are looking on the next standard, which is going to be released probably maybe next year, CoaXPress 3.0, we are using mainly optical transceivers with transferring 4 times 25 gigabit per second. So the standard itself allows to transfer 100 gigabit per second. Maybe there will be also copper standard specifications for transferring the same data rate with copper lines, but that's not sure because copper becomes very difficult to handle and the distance become quite short. So this is the history of CoaXPress. The practical organization of CoaXPress is very simple. You have a camera. For example, you have a camera from us where we are typically using all the 4 channels. You have just a coax cable, more or less standard with standard connectors. You need in the PC a grabber. And with the grabber, there's some software from the grabber manufacturing, who is organizing all the things. So the drawback of CoaXPress compared to USB or Ethernet is that you need a grabber. There are other advantages I will explain later on. How everything is organized in the CoaXPress 2.0 standard, we are using copper cables with 75 ohm impedance, standardized small or micro BNC or HD, high density BNC connectors. We have 4 times 12.5 gigabit downlink from the camera to the grabber. You can use up to 40 meters cable. 40 meters really optimistic. You need very thick cable with low attenuation. Typically, you're seeing 10 or 20 meters. That's easy. For really long distance, you can use the copper, the CoaXPress over fiber standard, which allows to nearly unlimited transfer length. And the advantage of this technique is also that each channel can provide a power up to 13 watts per channel. So you can drive your camera with the power from the host, from the frame grabber. This simplifies sometimes the organization and the installation of everything. What data are transferred? Okay, first, for sure, there is the video data from the PC, from the camera to the PC, but there's also status information and trigger information from the camera to the PC. And there's uplink transferring either trigger and or control data. So the camera is completely controlled from the PC also. And as I told you before, there is this power over CoaXPress possibility, transferring 24 volts up to 30 watt per connection. And you can have up to typically 4 connections. So this is the logical data transfer. Physically, the organization might be this way, that you have a grabber with 4 CXP connections, and you can connect with 4 cameras. So you have 4 independent data streams, video streams from different cameras at low frame rate for sure. At higher frame rate, you can combine 2 channels and have only 2 cameras, transferring 2 moderate or medium frame rate data streams to the grabber. Or what typically we are using in our cameras, we are using all 4 channels to connect to the grabber and to reach the really high data rate of 50 gigabit per second at the moment. But as I told you, we have plans, so we are introducing the 100 gigabit per second camera this year. Then the power supply can be either by external power supply connecting close to the camera, providing 24 volts, or alternatively, if you provide power from the grabber, you need to power the grabber itself with a special cable to the power supply of the PC, because if you're powering 4 times 13 watts, it's a lot of power, and it's not provided by the CoaXPress, the PCIe connector. The trigger signal is very similar. You can either trigger the cameras directly on the trigger input of the camera, or you can trigger the camera externally from the grabber, either by programming the grabber at a fixed frame rate. This is also possible for the camera. If you want to have just a fixed data rate, you can say to camera, okay, I want to have 500 frames a second, and it's doing itself. But if you need to synchronize it to external event, you need to trigger it externally. And you can provide this trigger signal either to the camera, or you can provide the trigger signal to the grabber, and the grabber is transferring the trigger signal to the camera by the CoaXPress interface also. There's no special cable. It's done with the same cables. Just a remark concerning the triggering. There's typical latency in the order of 10 microseconds and a trigger jitter of 5 microseconds. These are typical data. It's related to the fact that the data inside the camera are captured from the sensor and streamed directly to the grabber. Each line is read completely until the next line can be read. So if there's a line which is ongoing to be read and there's a trigger signal, you have to wait for end of this line until the triggering and the exposure starts. Therefore, there's some latency and some jitter in these things. Transferring the trigger signal via the CoaXPress interface adds a little delay because it's longer cable. but it nearly adds no jitter because there is a compensation on the data from the grabber to the camera compensating this jitter because the packets are transferred at a fixed rate. But with the packets, there's information when the trigger signal had been arrived compared to the data to this moment when the trigger package was transferred to the camera. Then we are continuing. This is the kind of logical presentation of the data and information, how everything is working. I would like to point out that inside the camera, we have an XML file. And this XML file describes all the possibilities of the camera. So it's describing how much integration time is possible, frame rate is possible, how triggering can be done, gain, special things like line skipping or binning. Everything is described in this XML file. It's transferred via the CoaXPress also to this GeniCam to C++ interpreter and made available to the GeniRP in C++. And this application then is provided also by the frame grabber manufacturer. And then it's either your application communicating with this application with a user interface or without a user interface. Typically for first steps, you can also use the applications provided by the frame grabber manufacturer. So we have a system where we have standard cameras in terms of hardware, but also software. And this software standard is called GeniCam standard. So you can exchange a camera without particular problems. Sure, if you have a camera with 1,000 frames a second and you use it at 5, and you have a camera with 100 frames a second, you need some change, some adaptations. But the control itself is done quite easily without really particular problems. Then I tried to compare the CoaXPress interface, which is shown here, this line, with different other interfaces, for example, GigE, external PCI, this is a very special thing. There is CLHS, the other standard derived from the camera link interface, and USB 3. You see the data rates are comparable. Okay, the external PCI is very high. CoaXPress at the moment with the actual standard, which is called CXP12 because it's 12.5 gigabit per second. Very similar. Here, CoaXPress allows up to 40 meters, which is much more than the 300 meters here or the 5 meters with the USB. But most important things are highlighted here. This is the key features I consider. With the CoaXPress, you have real-time capacity, which is sometimes more difficult for the GigE interface, and it's also sometimes more complicated for the USB interface. You have this real-time, and you are sure if you're triggering the camera, you will capture the image. There is no frame loss. And additionally, might be a disadvantage because you need a frame grabber, but you can do pre-processing inside the frame grabber. If you imagine you have 1,000 frames a second at high resolution, it might be very difficult to record this or to analyze this with the PC. So typically, many applications, there is a kind of pre-processing inside the grabber. And then the grabber are different. Different grabber manufacturer provide different possibilities how to do that, but you can typically do that pre-processing inside the grabber. And that's a big advantage over other applications. So from my point of view, that's all. I hope it was understandable. And if there are any questions, you are free to ask me. Thanks a lot for your attention.
Hello.
Yes, hello.
Yes, hi, Patrick. This is Rakesh from Laser Science. So actually, I have a question I have faced with the customer. Once we are selling the camera, so we need to ask the customer buy the software separately.
The power supply is typically not provided with the camera because the power supply is typically not used because most of the applications use this power over CXP. So the camera, the power supply needs to be provided separately. Theoretically, you can build your own power supply. You have just to purchase the right power supply, but that's specified in the user manual of the camera.
So my question is that we need to ask customer buy the software separately from the camera because
the camera we provide only the camera. You need to buy the grabber. Typically, with the grabber, there's some software from the grabber manufacturer, and then on top of that, either you are developing your own software or you are using just the software provided by the grabber manufacturer. Many cases you have a particular application. Many cases you need to analyze the images in a particular way only for your application. So you're probably forced to buy the software to build your own software.
Okay, actually, last month we have faced one problem. When was customer buy the camera and he bought the frame grabber from separate company, but that grabber company is not giving the software. He's asking that separate money for the software and license. So
okay, that's not our. We are selling the cameras. We especially did not propose or sell grabbers because there are many grabber manufacturers, and we do not want to interfere with their business.
Understand. So during the sales, we need to take care that we need to inform the customer. They need to buy the software separately according to their requirement.
Yeah. Just to well understand, we are talking about machine vision cameras. So these cameras are typically integrated in larger systems. So the customer should be aware that he is building a larger system, and he will need some grabber, some software, and I don't know what, a lot of other things may be around to do what he wants to do. We are not providing a complete full solution. We are not providing software and hardware and analyzing software for detecting defects in a product line or whatever.
Sorting and all of that. So one more question. When we are placing this frame grabber in the PC, we need to give that separate power supply to a frame grabber from the PC itself.
Typically, yes.
Okay.
But this is a standard connection. There are special cables from the PC sub power supply to this connections. I think this is very similar to video gaming boards.
Okay, thank you. Thank you so much.
Hi Patrick, I am Anubhav from R&D team. So it is similar question to follow up with what Rakesh was asking. So like what about the software development kit? We can develop our own synchronization with other system. As you said, like this is for bigger devices where other motion synchronization or other things can be done, right? So the machine level languages will be, or the codes will be given by you, right?
Can you repeat? I didn't understand.
I just want to know, when you are selling this thing, the SDK files will be provided by you, right? So that we can develop our own softwares. Is it?
We are providing the camera. Inside the camera, there's an XML file describing what the camera can do. And this XML file is typically read by the frame grabber manufacturer or by the software of the frame grabber manufacturer. And it allows to control the camera. So if you have the grabber with the software related to the grabber, you need the cables, you connect everything together, and you can already play with the camera. You might not be able to analyze the images according to your requirements. That's another issue. We are also supporting our customers if they have questions about image quality or control of the camera. This is what we can do. But we cannot, for example, advise how to program the algorithm to detect or to process the images.
Understood. Okay. So like say I want to use it for like a autofocusing or some motion synchronization, like on real-time machining. So like I can only analyze or see the images. I cannot post-process the things in that time, right?
We are not providing software for processing of the images.
Okay, understood.
We
What
are
is the
manufacturer.
maximum? Okay, frames per second it can capture.
Yep.
What is the maximum frames per second it can capture?
As I told you, we are limited by the bandwidth, and at the moment with CoaXPress Standard 2, we are limited to 50 gigabit per second. And if I go to the, I hope you see that. Just a second. You see it here. When we have 1 megapixel, you have up to 3,500 frames per second.
Okay.
And if you have a high resolution, 65 megapixel, you can go up to 70 frames per second. Just let me explain. If you reduce the readout area of the sensor, if you're not reading the complete sensor, if you're only reading half of it, you can double the frame rate.
Understood.
So there is a kind of drawback of compromise, and it depends how large the image area of the sensor will be for the readout, and then you have a higher frame rate. We have on our website a frame rate calculator. If you enter there the type of camera, and if you enter, for example, how many lines and how big everything is, he will provide you the information how many frames per second you can capture with the camera.
Thank you, Patrick. Understood. Yeah.
Yes, sir. Good.
Yeah.
Any more question?
Yeah, I'm having one question, Patrick. Yeah, is there any particular PC utility requirement kind of thing? Like this much RAM is required for the camera and other things. Any utility is required for that frame grabber and other things, or nothing? Like a normal PCIe slot, and then the power supply is fine for that.
I understand you want to have the information where there is a particular PC necessary.
Yeah, it's like it's recommended something. This much specification is needed for that system to work.
Yeah. To be honest, it should be a question asked the grabber manufacturers, because the grabber manufacturers are installing their grabber inside the PC. Very typically, all the PCs are okay, except if you want to have really special things. For example, we have one customer who is doing very high-speed processing of 2 cameras in parallel, and then he has a special PC with 2 PCUs. That's possible. So it depends a little bit on the performance of the PC and your requirement for the image processing. Okay. Or for example, if you want to install 2 grabbers with 2 cameras or whatever, then it might be necessary to have a special PC. But standard PCs are, for many applications, okay. But the question needs to be asked to the frame grabber manufacturer.
Okay. Thank you.
You're welcome. Any more questions? Maybe I just can give some information about the next generation of cameras. At the moment, the cameras are quite small. I did not mention the heat problems with the camera. I did not provide a file, but depending on your environment and depending on which camera is used, the camera might heat up, and so you might need to make sure the camera is cooled down sufficiently depending on your application. We have different solutions to do that. Just ask us or ask Laser Science if you think there's a problem. Heat dissipation also on the camera depends strongly on which camera, because the sensor inside the camera is producing a lot of heat and a lot of data, and this determines how hot the camera becomes. So from my side, it's all I would like to explain and to introduce. Okay, the heat is not a CoaXPress specific problem. It's a camera specific problem. And it will be even more critical with high 100 gigabit per second cameras. Okay. Are there any more questions?
Are there any more questions? Does anybody want to ask anything?
So, hi, Patrick. So, thank you. This is really nice information. So, I want to have one more question on bandwidth requirement. So, if I want to choose maximum frame rate, so what bandwidth required for the camera? Like Cyclone series, if I'm talking about Cyclone series, what bandwidth required?
I'm not sure whether I perfectly understood. So your request, you're asking the how to call it, the bandwidth requirement when you fix the frame rate.
Yeah, maximum frame
Okay.
rate. I want to achieve maximum frame rate. So, what bandwidth is required for the
Yeah.
camera?
You have to understand that bandwidth possibility depends on the grabber. On the
Okay.
example slide that you see, we have a limit at 50 gigabit per second. So we cannot transfer more than 50 gigabit per second.
Okay.
If your camera has, let's say, if you want to have 2000 frames a second, you're limited to 2 megapixel.
Okay.
But all these combinations, frame rate, resolution, are addressed with our frame rate calculator. So we have on our website a frame rate calculator. There you select the camera. With the camera, you have a maximum resolution. You can say, okay, I have this camera with maximum resolution of that. You can reduce the resolution. You can even say, I do not want to connect the camera with 4 lines to the grabber. I can only use 2 lines or maybe even 1. It's not always possible with 1, but sometimes it's possible. So you specify the camera, you specify the size of the sensor that you're using, you specify how many connections are used, and then the frame rate calculator provides the information how many frames per second are available. You still can go slower, but you cannot get faster.
Okay. Yeah. Thank you.
Patrick, there's a question on the. Oh, yes, Rakesh, so you can continue.
One more question. So as you mentioned, we can connect one coax cable from the camera. So is there any sequence where we need to connect a single lines or we need to connect a 4 lines from the camera to frame grabber?
I understood that you want to know why or how to define whether you connect 1, 2, or 4 cables to the grabber. Okay.
Yes.
We provide high-speed cameras, so we are always designing cameras to have 4 connections. For some applications, for example, if you want to connect 2 cameras to 1 grabber with 4 inputs, you only have 2 cables available. That's typically possible. The drawback is that the frame rate might drop. Maybe it's enough, depends on the sensor, but the frame rate will drop because the available data rate will be half only. Some cameras you can also connect only with 1 cable. The problem with 1 cable might be the frame rate is that low that's not possible. The problem might be to the architecture of the camera that we always need 2. That's also one possibility. And there is another thing. If you provide power for the camera from the grabber, you're limited to 13 watts. Some of the cameras require more power. If they require more power, you need at least 2 cables or power the camera from external power supply. So there are different limitations, not allowing to have the complete flexibility. On the data sheet of the cameras, we specify whether 2 or 1 cable is possible. And if you have any questions, let us know. Just ask what you want to do, which camera, what resolution, what frame rate, and ask whether 2 cables are okay or not.
Okay. Okay. Thank you.
Okay.
Okay.
Any more questions?
Patrick, there's a question on the chat box. Do you want to answer that, please?
I try to see the chat box.
Okay, do you want me to
Click on
read
the
it
right
out?
one. I think I have it. I have it.
Okay, okay.
There is a question I will just read to make sure that I have the right one. For the camera to be integrated with the automated system, how the calibration of the camera can be carried out. Is this the question?
Yes, that's the question. Yes.
Okay. Okay, I hope so. Typically, the camera does not need calibration from our point of view. This means the camera provides an image as it is. You can adjust gain, you can adjust offset, you can also adjust orientation or whatever. So at the moment, it's difficult for me to answer this question because I do not know what kind of calibration you want to do. So this is, if you want to calibrate, for example, the pixel size related to your object, that's completely out of our control because it depends on the lens that you're using. If you want to calibrate intensities, then that's different. What we are doing is we are providing also EMVA 1288 data. These data are characterizing the camera in terms of sensitivity, photon sensitivity, noise, and things like this. This might help a little bit to calibrate intensity or to estimate how much light you need. But for the question, it's difficult for me to answer, so I cannot really completely answer the question because I do not know what calibration means in this case.
Okay,
Is it
are
clear?
there any more questions? Okay, I think if there are no more questions, I think we can end the session now.
Okay, so thanks a lot for everybody.
Yes,
And
thank you, Patrick. Thank you for joining us. Thank you for your
okay,
time.
and thanks. Have a nice time.
You
Bye,
too.
everybody.
Thank you.
Yeah, thank you, Patrick.
Bye-bye.
Thank you so much.
Thanks.
Simran,
Yes.
can we have this PPT? Oh,
Sorry?
Thank you.
Rakesh, sir, you're saying something?
yeah, can we have this PPT, this presentation?
Right. I will get in touch with the marketing team and then they'll get it for you.
Okay.